Yeah, hello, good evening, welcome back. Okay, so we'll continue the question paper. So we are now on question 4. A bullet of mass m moving horizontally with velocity v hits a block of wood of mass big M resting on a smooth horizontal plane. Find a fraction of energy of the bullet dissipated in the collision itself. Assume collision to be inelastic. Okay, let us make a little revision on this. So we are having, I just represented the scenario diagrammatically. That is, the bullet is moving horizontally with the speed v, and this is the wood with initial speed 0. I just keep it that is at rest. That is the meaning of at rest. Okay, now we know that when we talk of collisions, basically there exist two classes. That is the oblique and the head-on. For the oblique, when the bullet was moving maybe at an angle to hit the block, maybe the bullet was moving something like this and came and hit the block, so it will be an oblique collision. But the bullet is moving horizontally, so that is a head-on collision at 0 degrees. And under these head-on collisions, there are basically three types. We have the elastic, inelastic, and the perfectly inelastic. But for time, we'll just talk on two. Elastic means that momentum is conserved. Initial momentum equals to final momentum. While same as kinetic energy, initial kinetic energy equals to final kinetic energy. But for inelastic collision, initial momentum equals to final momentum, same. But final kinetic energy is not equals to initial kinetic energy. That there is a loss in kinetic energy, and they're asking us to look for the fraction of that energy which is being dissipated. So that is what we will do. But we know that kinetic energy is given by this formula generally: 1/2 mv squared, where m is the mass of the body in motion and v is the speed with which it is moving. So our initial kinetic energy will be half mass and velocity of the block squared, because the velocity of the bullet squared, the block is not moving, so the block has no energy. So I can put here plus 0 joules. That is plus 0 for that block which is at rest, because half times m times 0 will just give 0. Now after the collision, what happens is that the bullet will be embedded into the block. All can move, or it can hit and come back. But at that moment, if it hits, let us assume that as it hits, it gets into the block or into the wood. In that case, the total mass now will now be m plus the mass of the block. And we are saying that now the final kinetic energy final, will simply half into mass of the bullet plus mass of the block times the speed with which they are moving. I put you all that squared. Let us first look for the change in kinetic energy. Change in kinetic energy will be initial kinetic energy minus the final kinetic energy, which I can look for the fractional kinetic energy of the with respect to the bullet. So I'll divide this by, let me say if I'm looking for the fractional Ke, that is fractional Ke that is being dissipated, will be Ke initial minus Ke final dividing by Ke initial, which can simplify to 1 minus Ke final all on Ke initial. Ke final all on Ke initial. So if the fractional loss in kinetic energy will be 1 minus half mass of the bullet, speed of the bullet all squared, dividing by a half into mass of the bullet, mass of the wood, and u with which they are moving, u squared. So it is the energy loss is by this, is given by this. So this is the energy lost. So if I was the one to set this question, I would ask to determine the fraction of the energy dissipated with the energy dissipated in function of the mass of the body only, the mass of the particles. So from there you can see it. But well, that is what the question was asking. It ends there. Then the other one is saying that question 5, if the formula n equals to negative d into n2 minus n1 on x2 minus x1. D equals diffusion coefficient. N1 and N2 are number of molecules in unit volume along x1 and x2, which represent distances where n is number of molecules passing through per unit area per unit time. Calculate the dimensions of D. So that tells us that N1 and N2 are number of molecules in unit volume. Okay, so N1, the dimensions of N1 equals the dimensions of N2, which is equals to dimensions of volume LQ. And it's telling us again that x1 and x2 represent distances. So x1, the dimensions for x1 is equal to the dimensions for x2, which is equal to distance, which is L, length. And n is the number of molecules passing through per unit area per unit time. N, the big N, is per unit area. Let me just put 1 on area times 1 on time per unit time. So dimensions of n, I can have it. Dimensions of area is length times width, so it will be distance squared, so it will be per square distance, and this one is on time, so per time. So that's the dimensions of that. So I would say this is the formula. Let me write it that n equals negative d into n2 minus n1 all on x2 minus x1. Okay, I will say let n2 minus n1 equals to p. So dimensions of p equals dimensions of n2 minus n1, which is equals to LQ, as the situation stated. Then also let x2 minus x1 equals to q. So dimensions of q will be equals to dimensions of x2 minus x1, which is equals to L. So I'll now be having that n is equals to negative d p over q, and from here I can make d the subject. So I'll be having nq over p equals d. I cross multiply with q and divide by p. So that's the d. So what are the dimensions of d? So dimensions of d will be equals to dimensions of n times dimensions of q all over dimensions of p. So dimensions of d will be equals to, we had dimensions of n to the length per square length per time, so per square length per time. The dimensions of q is L. Dimensions of q is L, length dividing by dimensions of p, which is LQ. So dimensions of g will be equals to indices. So this one I can take it up, so there will be L to the negative 2, this one is L to the 1, and this other one is L to the negative 3. That's a screw off, then t to the negative 1. If we add these quantities, we'll be having L to the negative 2, so we'll be having L to the negative 2 plus 1 minus 3 t to the negative 1 indices, and this gives us L to the negative 4 t to the negative 1. If I'm right, if n is per unit volume, then the equation will automatically change. But which type of d is this? Okay, so the dimensions of t. So I can conclude the dimensions of d is given by L to the negative 4 t to the negative 1. So that is it. Okay, if in case I don't see, I was thinking that it can be pair, so I don't know. So if it is pair, then we can still do the same procedure, but that's how you can do it. You just go to simplify those terms and let it to be a single term, rather than opening bracket trying to make subject the formula, which may lead to some errors. Okay, now